Hello. So let's do another example. And so again, like we've been talking about, what we're looking for when to see if we can even do U-substitution is we are looking for a composite function. So we're looking for an inside function and an outside function. And then the derivative of our inside function multiplied somewhere else in the problem. And so right away we have this cosine squared of theta times sine of theta d theta. And what we can think is that, this looks like a composite function. So if we rewrite this, we can rewrite this as the integral of cosine of theta squared sine of theta d theta. And then maybe it makes sense to say that our inside function, is cosine theta. So that's a guess. And then now we just need to think about how, what's the derivative of that u? And so let's maybe try that. So let's say u is equal to cosine of theta. And then du then is going to be, the derivative of cosine is negative sine. So negative sine of theta d theta. And in the problem, we don't have negative sine of theta d theta. We have sine of theta d theta. And so what we can do is we can multiply through by -1. We can multiply this equation through by -1. And so then what we're going to get, -1 du is equal to -1 times negative sine of theta d theta. And then of course, like this just becomes sine of theta d theta. Great. And so let's get rid of that and move this over. And so again, just to kind of talk about what we did was we identified, like an inside function. And so we said, okay, maybe that's our u, that's a guess. So we wrote down u is equal to cosine of theta, and then we took the derivative of it. So we said du is equal to negative sine of theta d theta. And we see that that does in fact actually work. We just need to multiply by a constant. So we have negative du is equal to sine of theta d theta. So let's write that. So this is going to be our u. This is going to be our negative du. And so then our integral is going to be the integral u squared times negative du. And we can pull out the negative. So this is going to be negative integral u squared du. And then again, so here hopefully it's really clear where the beauty of u substitution comes in. We started with a function that was kind of complicated. We have this cosine squared times a sine, like what the hackaroni is going on. And we changed it into like just u squared du, and this is much easier to evaluate. And so when we evaluate this, the antiderivative of u squared is just u cubed over 3. So this is going to be negative u cubed over 3 plus c. And then now we just substitute in our u. So this is going to be, and let's maybe rewrite this over here. And then this is going to be negative, our u was cosine of theta. So this is negative cosine of theta cubed over 3 plus c. All right.